this is your Kalpana here. In this video, we are going to see what is linearity property and first shifting theorem from Laplace transform. Okay, so let's start with linearity property. Linearity property. Prove that L of A into f of t plus or minus b into g of t is equals to A into L of f of t plus b into L of g of t. Okay. Proof. So we know that Laplace transform of L of Laplace transform of a function f of t, that is continuous function f of t, is equals to capital F of s equals to integral from 0 to infinity e power minus st into f of t dt. Okay. Now, consider the LHS part. Laplace transform of A into f of t plus or minus b into g of t. Okay. So, this is equals to, since we know that L of f of t equals to integral from 0 to infinity e power minus st into f of t into dt. Since we are having a plus f of t plus or minus b into g of t in the place of f of t. Now replace f of t with a into f of t plus or minus b into g of t in the formula. Okay. So we'll get integral from 0 to infinity e power minus st into f of t. Since we are having function a into f of t plus or minus b into g of t into dt. So this is equals to, since we are having two terms here, right? So we'll split the whole integration into two parts. So integral from 0 to infinity e power minus st into a into f of t into dt plus or minus integral from 0 to infinity e power minus st b into g of t into dt. Okay. So this is equals to, since a and b are constants, arbitrary constants, so you can take it outside the integral and you'll get a into integral from 0 to infinity e power minus st into f of t dt plus or minus, right? You are using two operations here. b into integral from 0 to infinity e power minus st into g of t into dt. Okay. Since we know that integral from 0 to infinity e power minus st f of t into dt is Laplace transform of f of t. So you can replace this with Laplace transform of f of t. So this is equals to a into L of, that is Laplace transform of f of t plus or minus b into, so since this is in the function g of t, okay, so you'll replace with g of t. If you'll replace with g of t, you'll get integral 0 to infinity e power minus st into g of t dt equals to L of g of t. Okay. So now you can replace integral from 0 to infinity e power minus st g of t dt with L of g of t. Okay. Since this is an actual formula, I am replacing it with f again. Okay. So now this is your RHS. We have proved the first property. But what is meant by plus or minus? Why they have given plus or minus? So, if you consider plus, L of f of t plus b into g of t is equals to a into L of f of t plus b into L of g of t. Okay. Also, L of a into f of t minus b into g of t is equals to a into L of f of t minus b into L of g of t. Okay. Plus or minus is nothing but if you have plus, then you'll get the formula like this. If you have minus, then this will be the formula. Okay. Fine. So now coming to first shifting theorem. First shifting theorem. If, first one, if L of f of t equals to capital F of s, then L of e power at into f of t equals to capital F of s minus a. And second one, if L of f of t equals to capital F of s, then L of e power minus at into f of t equals to capital F of s plus a. Okay. So here we have to prove two properties. Okay. So first one, if L of f of t equals to f of s, then L of e power at f of t equals to capital F of s minus a. And in second one, e power minus at. Here you are having e power plus at and here you are having e power minus at into f of t equals to f of s plus a. So let's begin. First one, proof. Consider, let L of f of t equals to capital F of s. Okay. We know that L of f of t equals to capital F of s equals to integral from 0 to infinity e power minus st into f of t dt. Okay. Now consider the LHS part. L of e power at into f of t. Since you are having function e power at into f of t. Now replace the function in the place of f of t, which is equals to integral from 0 to infinity e power minus st into, now I am replacing the function e power at into f of t into dt. Okay. So this equals to integral from 0 to infinity e power minus st into e power at into f of t into dt. Okay. So now you can write it as is equals to integral from 0 to infinity e power minus st plus at into f of t dt. So now in this you're having t common. So now we'll take minus and t common. Since you need minus in the power of exponential and t. Okay. So this equals to integral from 0 to infinity e power minus and t. I have taken minus and t common. So you'll get s minus a. Minus into s is minus s into t. Minus into minus plus a into t is at into f of t dt. Okay. So this is equals to, see, now compare this with the actual formula. Integral from 0 to infinity e power minus st into f of t dt is equals to capital F of s. Capital F of s. So this is equals to capital F of, in the place of s you are having s minus a. So you'll write s minus a. Okay. So we have proved the first one. So therefore, L of e power at into f of t equals to capital F of s minus a. Okay. Now coming to second one. So second one, if L of f of t equals to capital F of s, then L of e power minus 8 into f of t equals to f of s plus a. So we have to prove that L of e power minus 8 into f of t equals to f of s plus a. Proof. So let Laplace transform of f of t equals to capital F of s. Now consider the LHS part. L of e power minus at into f of t. Okay. Since we know that L of f of t equals to capital F of s equals to integral from 0 to infinity e power minus st into f of t into dt. Okay. So this is equals to, now replace f of t by e power minus 8 into f of t. So we are going to replace f of t integral from 0 to infinity e power minus st into f of t into dt. So now we are going to replace f of t with e power minus 8 into f of t. So this is your given f of t, right? So we are writing that f of t. So this is equals to integral from 0 to infinity e power minus st into e power minus 8 into f of t into dt. Since we know that e power a into e power b equals to e power a plus b. Okay. So you can write it as integral from 0 to infinity e power a into e power b equals to e power a plus b. So you'll add the powers. Minus of st plus at into f of t into dt. So this is equals to Integral from 0 to infinity e power minus of, now take t common, s plus a into t into f of t into dt. Okay. So now compare this with the actual formula. In the place of s, you're having s plus a. In the place of s, you're having s plus a, which is equals to f of s. So you will write it as f of, in the place of s, you're having s plus a. So you'll get capital F of s plus a. This completes the second proof. Okay. Therefore, L of e power minus at into f of t equals to capital F of s plus a. This completes the second proof. So in this video we have seen linearity property and first shifting theorem. Hope you will understand. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye.